Hello everyone, this is Gaurisankar,
Hello, this is Sannidhya.
and today we are working on phone price prediction. This is a multi-class classification problem. The dataset is available on Kaggle. The dataset attempts to classify phones into particular price segments depending upon the features and specifications that are offered with the phone. So dataset is available on
Dataset is
Kaggle,
available on
and the
Kaggle,
link
and the
is given
link
over here.
is given over here.
Coming to the background on dataset
Coming to the
details.
background on dataset
So a
details.
mobile phone is
So, a
priced in a
mobile
particular
phone,
segment depending upon its features and the specifications that are offered. The dataset given has two CSV files, a train.csv file and test.csv file. A train.csv file has around 2000 rows with 20 specific features. So based on this data, we are able to predict the accurate price range wherein a phone with a particular set of features must be classified or placed in. So we created the model in Colab and the link is given over here. Moving on to Sannidhya for the uh, introduction.
Yeah, hello everyone. This is Sannidhya, and I will be giving you more information about the dataset and the project that we have worked on. Uh, yeah, so this in this we can see. So in this we can see that there are first we'll talk about the libraries that we have imported for starting our project. This is the first library, the pandas library, followed by the numpys library, then the pyplot for like plotting any stuff, plotting graphs and all, and the last one is the sklearn library which helps us get the svm, which is the support vector machine. Coming next, these are the there are two data sets, basically train data set and a test data set, and this is the path for the train and test dataset which we have imported from the drive file. The Kaggle, as Gauri Shankar mentioned, that we took the dataset from the Kaggle link, and this is the Kaggle link from which we fetch the dataset for our mobile price classification project. Coming to the next part is that. As he said that data set has many columns and many rows, like 2000 rows and 21 columns. So this we have divided. So for just for the sake of classifying and just for understanding it, we have taken the dot head code. Using the dot head code, we have divided. We have selected the first five rows and 20 and the 21 columns from the data set for the train data set. Similarly we can see that for the test data set also we have done the same thing. The first five rows and the first five values and the 21 columns are selected for both train and test data set. Coming to the shape of the data set, which is the shape of the train and test data set. Now what shape determines is basically when a data set is there, there is rows and columns, and when we think about the rows and the columns, the first thing that comes to our mind is the matrix. So considering it as a simple matrix, we can see that the shape of the matrix is basically the number of rows and the number of columns present in that data set or the matrix. So in this case, we see that in the train data set, we have 2000 rows and 21 columns, and test data set has 1000 rows and 21 columns. These columns are basically the different types of features of a different mobile phone has, and by that which can help us in determining the price range later on, and thus the category which under which it falls. Now talking about this code, the CORR, that's the core correlation. This In this correlation thing, we will basically determine the price range. The correlation thing will help us determine the price range of the different types of different mobile phones. But and because the price range will help us determine the category under which it's going to fall, it should always be a positive number. But by this code we define different price ranges, but we see that there are few values like this. The third value is 0 point mine, this is negative, which is as this value is also negative. So what this negative determines, so this negative basically determines is that such type of data set or the price ranges are irrelevant to our project or irrelevant in this context, because hence we should remove them, because all that matters is the positive price range, which will help us determine the category later on. So for we should what we should make sure is remove this negative price ranges from the data set. Now, how will we do that? This is what is basically we call as data cleaning. So, according to with this code and the drop code, we will just remove the negative values that we have come across in the price range in the data set, and we'll be left. So, when we from the trained data set basically, so we'll drop the negative values and we'll be left with. And so, because we saw here there are three negative values, one, two, and three. So basically, we need to remove three columns from the from our data set. So earlier, as we know, there were 21 columns. So after removing the three, we will be left with 2000 rows and 18 columns, which is all positive values, and that's all that's what we need. So now again, going back to Gauri Shankar, who will give more information about the optimizers and all the other stuff.
Coming on to the optimizer use, there are several optimizers for ascertaining the optimal parameters. As some of the more popular optimizers are SGD, gradient descent, and simulated annealing. In this model, we have used grid search CV, which works in a simulated annealing fashion to ascertain the parameters with the least cost and high accuracy. Here, what grid search CV does is creates a grid of parameters and ascertains the parameter with the highest accuracy by running all parameters and ascertaining the one with the highest accuracy. C here is a regularization parameter, and we have obtained that C10 would be the most appropriate value for the regularization parameter, and gamma is the kernel coefficient, which is 0.0001, and kernel is RBF. RBF stands for square exponential kernel. It is the default kernel that is used. Moving on to the Colab file. DF train, we are checking the DF train for any null values which require to be eliminated before running the model. And we have found that there aren't any. Checking this test, now we have to split the test data set, the train data set, to apply it on the test data set and check for the accuracy, original accuracy. So we have found that the test dataset has around 1,000 rows. Hence, we need to split the train dataset into 1,000 rows as well. This is because while mapping the values from one dataset to another, we need the columns to we need the number of rows to be equal, and hence we use a 0.5 ratio for splitting the train dataset into train. So the train dataset is split into validation dataset at a ratio of 0.5. So 1,000 columns are used for training the values, and we're printing the shape of the test and train datasets that we have obtained over here. And this is the grid search CV file that we had shown you earlier. Train accuracy testing the model using the validation dataset yielded an accuracy of around 1.0 on the train dataset. Now, on the validation dataset, it gave us around 0.556, which translates to 55% accuracy. Coming to the classification report, we had we got a F1 score of 0.56, 0.56, 56 or 56%. Moving on, moving on to the parameter tuning details. Parameter tuning, we have optimized the values as we have seen, as we had shown you earlier. There weren't any null values, so there wasn't much left for us to do. And the correlation metrics parameter, we were able to ascertain the negative values from the correlation metrics, and hence, and we have deleted those features, as Sannidhya had mentioned before. And moving on to algorithm, coming to the algorithm, there are various algorithms such as XGBoost, random forest, and we have chosen SVM here because it yielded relatively good accuracy. And as shown earlier, the regularization parameters and other details are mentioned over here. And moving on to the results. Our model achieved an accuracy score of 1.0 on the training dataset and a 0.556% 0.556 score on the validation dataset. Now, we had used the second dataset. This is basically the test.csv file to test our model to yield a more accurate analysis of how efficient our model is. As we see here, we have used the predict command to work on it, and we got an accuracy of 0.24, which is relatively low, but I believe we can improve this by applying more extensive feature classification and a better optimizer. Moving on to Sannidhya for the learning outcomes and other details.
Yeah. So now we'll be discussing. So in the end, we'll be discussing about the learning outcomes. learning outcomes, and uh, and hence and we'll be capping off this video presentation with the learning outcomes. So they are the learning outcomes from this, of what we learned from this project is is basically we got to know how an AI model can be functioned in such a way which can help us determine for this particular case. So how an AI model can be help like function in a way which can help us determine and classify different mobile phones under various price range categories. And we also got to know about the various optimizers. We studied about the optimizers in our regular theory classes, but by this project we got to know about how the different types of optimizers which are like used in making a desired AI model, and also about new concepts such as classification, hyperparameter tuning, as discussed by Gaurisankar, optimization, and we are also able to gain insights and gain more information and knowledge about the diverse ecosystem of our machine learning. It's a very widespread and vast concept, so we got to know more about it. And we also learned that the AI model can be built in such a way that for this particular case in such a way that it can help us determine the phone price range category with a very reasonable accuracy, which as mentioned earlier can be increased by using much better optimizers. Also we got we have got a good hands-on experience about working on different types of data sets. And so through this project we also worked on complex and much larger data set and collecting desired information from them, and to build an AI model which will give us reasonable accuracy and the output that we actually want to have from the model. Also from this also we like as I said different we learned we had an experience of handling different data sets for different scenarios, and it helps and as we know that being an AI students we have to study machine learning when we go for higher studies or probably in future as well. So this small project helped us have a great familiarity with what machine learning and deep learning is all about and its various concepts, and this will help us for, as I said, this will help us further going forward in AI. Thank you.
Thank you.